Hello, welcome to BoomBox7. This is the block diagram of our project. As you can see in the figure, we have Bluetooth module, DAC, MCU, filter, Class D amplifier, and volume control. In Sprint 1, we will show you the details we designed. For the BM64 module, we have decided to group the pins by functionality. This is why all these I2S, UART, LED, power, AUX, volume and sound control, configuration control, and system configuration have been grouped together by the categories. On the top of that, we have decided to leave pins open that will allow for further improvements. This is why we have left the AUX pins and the volume and sound control pins as well. These features will possibly be implemented later on. In this DAC part, we build the circuits according to the datasheet. We also add the voltage regulator to the board because in block diagram, the voltage input wire of the DAC is 5 voltage, but the input voltage should be 3.3 voltage. Therefore, the voltage regulator is necessary. In our filter part, we decided to use the 4th order Butterworth low-pass filter with chip LM741, which is very cheap. We try to keep the cutoff frequency at 20 kHz. First, we simulated the cascade circuits in Multisim for both right and left channels. It shows the perfect quality that we desire. And then we use the Eagle to design the schematic and the PCB board. The Class D amplifier we will produce has a TPA3122D2N IC chip that works as an audio amplifier. The chip works internally with a half-bridge system which is preferred for a 2-channel output. The schematic used is based on the schematic on the datasheet and the website. The input will be 2 channels left and right, which are decoupled and grounded. The chip can also be controlled with a mute and shutdown button for extra control. The output stage has 2 woofer channels that are first lead through a low-pass filter stage. Also, there is a gain control which is not used, so it is 0, 0. This will give a typical 20 dB gain.